We will proceed in gradient vector and we will calculate the surface area of a sphere through a spherical coordinate system. We have done all permutation and combination. We had Cartesian coordinate system and then through that we calculated the surface area of a sphere. Okay, we had Cartesian coordinate system and then we calculated the surface area of a sphere. So this is what that is already seen. Okay, now the question arises is that can we what we did till now. So question is arising that what we did till now. So what we did till now is that we calculated the curve length of a circle. If I have a circle, if I have a circle, then I calculated the curve length. Okay. Now, what is the beginning point? Beginning point is the algebraic equation of the circle. Okay. So circle has the algebraic equation. Like this circle has algebraic equation x square plus y square equal to radius square, that is a square. Then as per the as per the uh, as per the algebra, this is the equation. Whereas as per the calculus, then it is y equal to a square root of a square minus x square. Now anyway, now if I have algebraic equation x square plus y square equal to a square, okay, then its gradient vector is 2xi plus 2yj. If this is the circle equation, this is the circle equation. If this is the circle equation, then this is the then radial is the its gradient vector x 2xi plus 2yj x square plus y square. If we do partial derivation gradient vector, if I get, then it will come 2xi plus 2yj. So if x square plus y square is the equation of the circle, so if I go with the algebra and calculate the gradient vector, then this is how it is. Or this algebraic equation I can change into position vector. If I change into position vector where any point x comma y if I take and from center if I draw a vector, so this point is P, from center if I draw a vector, then it is xi plus yj. Any point if it is x comma y p, then p equal to xi plus yj. This is a kind of vector representation of algebraic any algebraic point x comma y. Okay, if that is the case, then p equal to xi plus a square root of a square minus x square j. If I go with the calculating the gradient of this vector, then it will become dp by dx. There is only one independent component, dp by dx equal to 1 I means I minus x by square root of a square minus x square j, that is dy by dx. So dp by dx, with p equal to xi plus yj, then dp by dx equal to I plus dy by dx j. This is also called velocity vector. So if this is the position vector, then velocity vector is gradient vector is tangential. If tangential is along the curve, then if I calculate the magnitude, then we will get the curve length. We cannot calculate the magnitude because this is gradient vector, velocity vector. If it is velocity vector, then we have to first integrate it to get the displacement vector. If this is velocity magnitude, if I have a position vector, if I calculate the gradient of it, then that gradient vector is a velocity vector. If I calculate the magnitude, then it is the velocity length magnitude. If I integrate it, then I get the displacement magnitude. This is what we want the curve length. Similarly, in 2D, in 3D where things are not line, they are surfaces. Okay, like one surface is the ball, so that is sphere. If I have a sphere, then any point on the ball P, if ball is centered at the origin, any point P on the ball, if I draw a radius, okay, so if there is any point P on the ball and then I draw a position vector on the ball, okay, then that point is xi plus yj plus zk. Then I have to, if I consider xy plane, this is x-axis, this is y-axis, and this is fxy or z. So if this is xy plane, x-axis, y-axis, this plane is xy plane. If I have a position vector that is xi plus yj plus zk, P equal to xi plus yj plus zk, dp by dxy plane, dp by dxy plane would give me the actual gradient vector, velocity gradient vector. That vector will be, if I had 2D, then that vector was tangential at every point on the curve. But if I have 3D, then that will be tangential surface at any point on the surface. That is dp by dxy plane. So dp by dxy plane, the xy plane, how we calculate is we calculate dp by dx and then we calculate dp by dy and do the cross product. So cross product in the sense that if I have two vector, then cross product would give area in between. If I have two vector, then cross product of these two will give area in between. So that is, if this is xy plane, then cross product will give the, if this is x axis and this is y axis, then cross product will give the xy plane. So dp by dxy plane is nothing but dp by dx cross dp by dy. So dp is xi plus yj plus zk, dp by dx is I plus dz by dxk, dp by dy is k plus dz by dy is j plus dz by dyk. If I do cross product, then I get minus dz by dxi minus dz by dyj plus k. This is velocity surface vector. If I calculate the magnitude, then it is dz by dx whole square plus dz by dy whole square plus 1 square root. Now this, whatever the velocity surface magnitude we are getting, this is an algebraic equation. I have to do integration with xy plane. So integration sign and then square root and then dz by dx whole square plus dz by dy whole square plus 1, then d area, that is dA, that is area is xy plane. So this much we have seen. Now can we proceed in a spherical coordinate system? So spherical coordinate system, the xy plane has two orthogonal components. One is radius and one is theta angle. So if this is a sphere and a sphere is centered at the origin, then at the xy plane, that is equatorial, if I make a cut, then it will be a circle on the xy plane. Consider that circle is this. Consider that circle is this. If this is the circle, now actually circle is on xy plane, I am just rotating it, then one orthogonal component is radius and other orthogonal component is theta that moves 360 degree. Radius moves 360 degree. Okay, so theta and radius, how theta and radius are orthogonal to each other in a sense that if there is a theta movement, if this is the radius 0 degree angle, if there is a theta movement, then movement happens along the arc. So theta, every angle, every arc, if I take this section of the arc, this arc belongs to one angle at the center. If this arc belongs to an angle at the center, then this arc and this radius are perpendicular to each other. So they are orthogonal to each other. Okay, one thing. Second thing is, what is third component of a spherical coordinate system? One is theta, one is r. Third component is phi. Since it is a sphere, so radius, if I take in xy plane, that is radius. Otherwise, radius is everywhere. 3D, xy plane. So consider there is a vertical line. From vertical line, radius make phi angle. Radius make phi angle. This makes vertical arc. If on horizontal xy plane radius make theta angle, then this makes an arc. If from vertical, if radius makes phi angle, then again this makes an arc. This arc and this xy plane arc are perpendicular to each other. And this Mr. Radius is perpendicular to this arc also. On xy plane, it is perpendicular to this arc also. All three are perpendicular to each other. But anyway, now question is arising, what is the surface area? Surface area is integration of the velocity surface magnitude. I have to integrate velocity surface magnitude with dxy plane. That is the square root of dz by dx whole square plus dz by dy whole square plus 1 dxy plane. Okay. Now, if that is the case, then what is xy plane? One thing. What is xy plane? What is dz by dx? What is dz by dy? Question arises. What question arises? Question arises is, can I find the surface area only in a spherical coordinate system? That is the question. Can I find this spherical area, sphere area only in a spherical coordinate system? So we have dz by dx, dz by dy, where xy plane is what we are considering as the base independent component. Here, xy plane moved to r theta plane, radius theta plane. This is what we see because phi is vertical. So if that is the case, then dz by dx becomes dz by dr. Dz by dy becomes dz by d theta. These are two orthogonal components on x-axis converted to r and theta y converted to theta. If that is the case, now the velocity surface magnitude is square root of dz by dr whole square plus dz by d theta whole square plus 1 dA. Area is nothing but r d theta dr. R d theta dr. Everything is crystal clear, right? Earlier we had dp by dxy plane. dp by dxy plane equal to minus dz by dxi minus dz by dyj plus k. If I calculate the magnitude, then it becomes dz by dx whole square, dz by dy whole square plus 1. Everything came into the picture because p, the position vector, is xi plus yj plus zk. dp by dx is I plus dz by dxk. dp by dy is j plus dz by dk k. But actual what we want is the dp by dxy plane. dp by dxy plane. That is the actual gradient vector of position vector p. That is actual gradient against the xy plane. So dp by dx is dp by dx, dp by dxy plane is dp by dx cross dp by dy. If that is the case, then these two cross I have to make. One is dp by dx is I plus dz by dxk. dp by dy is j plus dz by dyk. If I do cross product, it becomes minus dz by dxi minus dz by dxi minus dz by dyj plus k. If I calculate the magnitude, then it becomes dz by dx whole square plus dz by dy whole square plus 1 square root. So the velocity, the gradient of the gradient vector, that is velocity surface vector, that is dp by dxy plane. dp by dxy plane is minus dz by dxi minus dz by dyj plus k. If I want to have velocity magnitude, then a square root of dz by dx whole square plus dz by dy whole square plus 1. Okay, if I want the surface area, then I have to calculate the integration of this velocity surface magnitude. So integration of square root of dz by dx whole square plus dz by dy whole square plus 1 against integration against dxy plane, dA. Now dz by dx is changed, is transformed into dz by dr. We are taking full spherical coordinate system. In that xy plane is has two independent variables r and theta. The xy plane is r and theta. So so the surface area is integration of velocity gradient with the xy plane. So integration of velocity, magnitude of velocity gradient is dz by dx is now dz by dr and dz by dy is dz by d theta. So now it is square root of integration of a square root of dz by dr whole square plus dz by d theta whole square plus 1 d of the xy area, plane area. So dxy plane area is r d theta dr. R d theta, that is the r. If I take xy plane, then r d theta is this arc. If this is xy plane, then r d theta is this arc, and then radius. If I take a small area section, then one side is radius dr and other side is r d theta. So r d theta dr, that is dA. So now square root of dz by dr whole square plus dz by d theta whole square plus 1 r d theta dr. Everything is nice where r is from 0 to a. Radius will go from 0 to full radius a, where theta will go 2 pi. But problem is, what is z? What is the height? Dz by dr, all right. Dz by d theta is all right. But what is z? So that is under question mark. What is z? Okay. Now let's take this sphere again. This sphere at equatorial, I make a cut and that is a circle. Let's make a cut, two cut. One cut is at the equatorial and one cut is at height h. This height is h, full height is a, that is the radius. If I cut here and cut at height h, again there will be a circle. On top there is a circle and at equatorial there is a circle. The equatorial circle or xy plane circle, the radius is radius of the sphere, that is a. But at height h, if I make a cut, that sphere, the circle is small. Consider that radius is r and height is z. I said h. Consider z, that is the height. Dz by dr, that is the height. What is the equation of z? If I cut at this level, the height is z from the xy plane. If I cut it, then consider this as z. This is xy plane. If this is z, and this is a, then this is r. This r is smaller than this a, that is hypotenuse, the actual radius of the sphere. Then this height equal to this hypotenuse minus r. R is the radius at this cross section. At center the cross section, the radius is a, that is the radius of the sphere. If I move z up and make a cut again, that radius is r. So if this is the height z and this is the radius r, then this is the a, that is the hypotenuse. So z equal to a square minus r square. A square minus r square. If that is the case, z equal to, z square equal to a square minus r square. So z is equal to square root of a square minus r square. Now again we will see the surface area is integration of the velocity surface magnitude, velocity gradient magnitude. So integration of a square root of dz by dr whole square plus dz by d theta whole square plus 1 r dr d theta, r d theta dr. Now z is square root of a square minus r square. Square root of a square minus r square. Dz by dr is minus r divided by square root of a square minus r square. Dz by d theta is 0 because there is nothing there. So now we are calculating a square root of minus r, square root of minus r whole square. dz by dr is minus r divided by square root of a square minus r square. So now we have a square root of this whole square plus 1. So square root of r square divided by a square minus r square plus 1. If I settle it, then it becomes totally a square divided by a square minus r square root. Then it becomes a divided by a square root of a square minus r square. So final surface area, this solution is not available in the book. If you want to support us, then please support. This is our kind of one, that is, I believe that is the responsibility on the people who are learning through us, that please support us. So this solution is not available in any of the book. Okay. So the kind of, now we are talking about calculating the surface area. So surface area is a by square root of a square minus r square. A square by a by square root of a square minus r square. R d theta dr. A, I'll bring it out. This solution is not available in any of the book. So integration of a, divide a outside. So 1 by square root of a square minus r square. R d theta dr. R d theta dr is dA. dA. If it was Cartesian coordinate, then it would have been dx dy. But it is spherical coordinate system where the xy plane transform into r d theta dr or r dr d theta. So a is out. Now we have to integrate r by a square root of a square minus r square. Okay. Now this integration sign becomes two integration. One integration, r is from 0 to a and theta is from 0 to 2 pi. R is from 0 to a and theta is from 0 to 2 pi. Okay. Now r divided by square root of a square minus r square. What is the integration of this? The integration of this is minus a square root of a square minus r square. Minus a square root of a square minus r square. If I do the differentiation of this, then minus 1 square root of a square minus r square would be 1 by 2 1 by 2 into 1 by square root of a square minus r square into minus 2r. So 2 to cut down, minus cut down, r by square root of a square minus r square. So the kind of the integration of r by square root of a square minus r square is minus square root of a square minus r square. If I place limit 0 to a, if it is a, then it is 0, a square minus a square. But if it 0 to a, if I place a, it is 0. If I place 0, first minus will go away because it is lower limit, and then it is a. Outside a we have already kept, this is a square. Now integration of theta. Integration of theta is theta. Limit is 0 to 2 pi. So 2 pi a square is the surface area. But if you remember, we took the xy plane and height we took from the xy plane, that is z. So we are calculating the top hemisphere spherical area. Top hemisphere spherical area. So if it comes as 2 pi a square, then the full sphere area is 4 pi a square. 4 pi a square. So 4 pi a square is the surface area of the full sphere, 4 pi a square. Okay. Someone can proceed and he can try the way we calculated, right? The surface area. Someone can try calculating the volume also. Calculating the volume also. This is not part of this discussion, but we will discuss it little bit. Anyway, what we have seen till now, if I have a gradient vector, if I have if I have algebraic equation, like algebraic equation of a sphere is x square plus y square plus z square equal to a square. So z equal to a square minus x square minus y square square root. This is Cartesian coordinate system. Whereas a spherical coordinate system, z is nothing but square root of a square minus r square. This is what we saw. So if I have algebraic equation and I calculate the gradient, then gradient vector is perpendicular to the algebraic curve. If I calculate the gradient of this sphere, then gradient vector would be perpendicular to the surface. If it is z equal to square root of a square minus x square minus y square. But if I take this algebraic equation as position vector and calculate the gradient vector, position vector's gradient, then gradient vector is a surface which is tangent on the surface. Okay. Then if I take 2D and calculate the gradient of position vector, that is a line that is tangent, then that is a derivative along x-axis. If it is trying to differentiate the position vector of a sphere, then it is derivative along xy plane, not only x-axis. To get the derivative along xy plane, we calculated dp by dx cross product dp by dp by dx cross dp by dy. This is how we get derivation along the xy plane. This explanation is not available in any of the books. You can try it. How they explain it, the way I am saying, calculating the surface area, how they proceed and how they explain the cross product, it is beyond anyone's brain. It is something like they know the result and somehow from source to target, they have to meet, they have to tie one rope. That's it. Some fundamental they give and they just write this is how it is. But actual is that you have to have one independent component. So that is the idea. Now, can we calculate the volume of the sphere? If I want, if basic calculus, the basic primitive calculus that we have uploaded tons of videos. So in primitive calculus, if I have a line, if I have a line, and if I calculate integration of the line, then I get the, if if this is x-axis and this is a line equation, if I calculate integral, then below it we get the surface area. Integral of this line, then I get the surface area. Like that, if I have xy plane, on top of it if I have a surface, and if I integrate this surface along xy plane, if I integrate this surface along xy plane, I get the volume. If I have x-axis and if I have a line equation, if I do integration, I get the surface area. Or to get the surface area, I calculate the integration. Like if I have xy plane and if there is a surface on top of it, if I do integration of the surface against xy plane, one single independent component, then this will give you the volume. So if I volume of a sphere, then a sphere equation I have to find, and if I calculate the integration along xy plane, then I get the volume of the sphere. What is the equation of this sphere? What is z equal to, or what is fxy? Z equal to square root of a square minus x square minus y square. So integration of fxy along the xy plane. So integration of a square root of a square minus x square minus y square dA. If I go with the Cartesian coordinate, then integration of a square root of a square minus x square minus y square dx dy. If I calculate this, I get the volume. Then integration of x is minus a to a, because if this is a sphere and if I pierce this, then left side is minus a of the, that is the radius, minus a to plus a, minus a to plus a. Okay, okay, I believe we can proceed on this. Okay, so we will proceed on this, and that will be the end of the tutorial. So that is that kind of calculating the, that is kind of calculating the volume of a sphere through primitive calculus. So primitive calculus, that is fxy dA, integration dA, that is dx dy. Dx dy is dA in Cartesian coordinate system. So dx dy is surface area, dx dy is dA in Cartesian coordinate system. If I go with cylindrical coordinate system, then dA is r d theta dr. If I go in a spherical coordinate system, then dA is a sine phi, a sine phi. So a sine phi is the radius. So a sine phi dA sine phi d theta. Okay, so all three we will see, that is dA. Now square root of a square minus x square minus y square is the z, that is the height. So z would change. So z would change. In Cartesian coordinate system, it is square root of a square minus x square minus y square. In cylindrical coordinate system, it is square root of a square minus r square. This is what we have seen. Same in a spherical coordinate system also, it is square root of a square minus r square, where the r is at any moment, it is a sine phi. Phi is the angle from the vertical. So that is the case. So we will see it. We will not run away. So all three coordinate systems, that will be in, because that is may not be part of a gradient vector, but it will clean up the concept of gradient vector. So we will see that kind of how we can calculate the volume of this sphere through the primitive calculus, basic calculus. Okay, so just kind of finishing touch for this, so that we will see.